Welcome to Moogfest 2018. We are here at the Moog pop-up factory in Bay 7 of Durham's American Tobacco campus, where we are building a brand new Moog instrument, the Moog Grandmother. Grandmother is a semi-modular analog synthesizer with a built-in sequencer, arpeggiator, and spring reverb tank. We are debuting Grandmother here at Moogfest for the first time, and as part of the Moogfest experience, we've brought up our production engineers from our Moog factory in Ashville to perform a live build of the Grandmother synthesizer here at Moogfest. This is Mark.
Yeah, Mark saved me on my subharmonicon build.
So Mark is in our engineering department. This is Angie. Angie's one of our production engineers. And then Siobhan is, what's the title now?
Official title?
Yeah.
Production manager.
Production manager. But she's a magician and makes sure that everything happens. So much more. All of our instruments that we build in the Moog factory are built in teams. Nothing that we do is done by one person alone, whether that's the design and engineering of our products back in our factory at Ashville, or the production and manufacturing. So for the Grandmother build, we have 4 different stations. So the first step in building the new Grandmother synthesizer is that we're going to pull out the analog circuit boards, and we're first going to do a visual inspection of all of the components to make sure that all the solder joints are correct and that everything is robust. Then the next step is we're going to flash firmware onto the circuit board, and this is going to allow us to begin our calibration process. Calibration for an analog synthesizer is very important. Analog circuits are living, breathing, organic circuits, and it's important that they have a human touch, human hands and human eyes and ears following along on every step of the process. So when we do our calibrations, what we're doing is we're really tuning the instrument. Just like a guitar needs to be tuned, a synthesizer needs to be tuned as well. After the boards have been calibrated on station 1, we move over to station 2, where the instrument starts to take shape. Station 2 applies the front panel overlay as well as the back panel overlay. This is where you get all of your information about what your controls are, what your IOs are. In addition to applying the overlays, Station 2 begins to assemble the physical body of the instrument. The side panels and the internal side shields that protect the circuits inside from outside electronic interference are installed. And then once everything is ready to go, the analog circuit boards are married to the front panel. All of the washers and nuts are put on, and everything is secured together.
Is this the same way that it is in the factory itself?
Yeah.
4 stations?
Yep.
That's how. Cool.
Yeah.
Nice.
This process is exactly like it is in the Moog factory. We've essentially brought the whole line from Asheville here to Durham for Moogfest this weekend. At Station 3, the key bed is installed into the bottom plate of this synthesizer. We also make all of our LHCs on Station 3. So the
What's an LHC? Yeah.
Yep. The LHC is the left-hand controller, and it's this part right down here. This is your pitch and mod wheel, as well as your controls for the arpeggiator and the sequencer. Station 3 also installs the digital board into the synthesizer. The digital board of Grandmother is where the arpeggiator and sequencer live. And then
what does that look like?
That is this one right here.
This guy.
Yeah.
So inside there's basically 2 boards.
There's 2 analog boards and then the digital board. The spring reverb tank is also mounted onto the bottom panel here at Station 3.
Where's that?
That is right there.
Oh, hold on, that deserves its own.
Yeah, the enclosure holds the spring, so it's about that long. It goes right through there. Grandmother's spring reverb tank is based on the spring reverb from our classic Moog modular synthesizers. Adding spring reverb to a synthesizer really allows a whole new dimension of sound to come out of the instrument. There's just something magical about the way that a physical spring sounds. You start to get all of these new harmonics introduced that are brought out of the original sound, and it really brings the instrument to life.
Very nice.
So key bed, left-hand controller, spring reverb go in, the digital board gets added at station 3, and then everything gets all hooked together with the ribbon cable. So what Justin is doing right now is he's taking these ribbon cables and he's connecting the keyboard to the circuit board to the left-hand controller. All of the analog boards, all of the digital boards all get hooked up, and now the instrument can talk. You know, everything is hooked together and the instrument can function as it should.
Beautiful.
Yep. So, all right, and then we'll go here.
Sure.
After station 3, all of our synthesizers will go through a 24-hour burn-in process. During this burn-in, we have the instruments plugged in and turned on, and this simply allows voltage to run through the entire circuit for 24 hours. An analog synthesizer is comprised of thousands of small, discrete analog components, and we need a way to check that each one of those components is going to be robust. So through the 24-hour burn-in process, if there's a resistor that's going to pop or an LED light that's going to burn out, it'll happen in that 24 hours, and we can address the problem on the bench as opposed to 2 months into someone's studio. After the 24-hour burn-in process, the synthesizer is brought to station 4. This is where we perform our final listening check. Every major function that the instrument is designed to perform will have a human being step through those processes to ensure that not only is the performance correct, but that the experience of interacting with the instrument is perfect as well. So at station 4, they're going to use oscilloscopes and multimeters and different measuring devices to be able to see what's going on inside the circuit. We're looking at the wave shapes for the oscillators. We're looking at the MIDI information that's coming in and out of the instrument. We have a Mother 32 here that we use to test connectivity. Grandmother is designed to integrate seamlessly with our Mother 32 and DFAM synthesizers. Once the final listening test is complete and everything is signed off on, we put the rest of the knobs on the front panel and we're ready to send it out to a customer.